Hello, this is Alan Folsby, and today's subject on theoretical physics is the cosmology of eternity. Technetium and molybdenum show the way. The theory is based on actual facts of the periodic table. Elements 43 and 42 show the way. Hello, welcome back to the Maui Theoretical Physics Laboratories here. November 22nd, 2019, live, the Cosmology of Eternity. So this will not last an eternity, but to give you an example of what eternity is really like, consider 4 seconds of silence. Now, that was an eternity for radio, but this is live YouTube streaming, and this is all for free. I could just sit here for eternity. Technically, I could simply wait out Alphabet and Google and YouTube's financiers and just continue broadcasting for hours today. But I'm not going to do that. I'm not that kind of a theoretical physicist. This will only take a half hour. Now, technetium and molybdenum are like fossils. We can look into the crust of the Earth in the fossil record here, and we can see what is still existing. There's plenty of molybdenum, and what got eliminated and did not survive as nuclei, like technetium or promethium. Those are extremely rare. Now, the cosmology of eternity is big enough an idea to encompass the Big Bang. That happened in the middle of eternity. The Big Bang happened right in the middle of eternity as expansion was continuing at the same type of accelerating rate it was expanding at back then. And during eternity, of course, the 14 billion years we talk about commonly is just very small. And the Big Bang could have taken 1 trillion years, and it would have just expanded at the calm, serene rate we see today. But from our perspective, it looks like a bang. Looks like it could be a few seconds, or back 100 trillion years ago, it could have been a simple cubic lattice like a giant neutron star, encompassing all matter in the universe, all protons and electrons, and all neutrons, combined into a region about 10 light years cubic, and it was packed very tightly together as it expanded. And some was simple cubic, some was hexagonal close pack of the spherical baryons. Now, today, we can see that in the theory I'm proposing, there is still a simple cubic lattice at the center of most nuclei, like molybdenum. And I'll be going into details on that. But I'm going to go back to these PowerPoint slides here for a second. I'm having a little audio trouble here, and I'm just going to be figuring it out for a second here. I'll go to the PowerPoint and see if I can get the audio going there. Now, this seems to have it working now. Thank you very much. Now, going to the title. was Cosmology of Eternity. My name is Alan Folmsby, and I'm on 3 days a week at this time. 20 hours GMT, Greenwich Mean Time, Monday, Wednesday, and Friday. Today is November 22nd, 2019, right in the middle of eternity. Just like the Big Bang was in the center of eternity, and 100 quadrillion years ago, things were much tighter than they are now. I've spoken about this periodic table before, and how a cubic lattice is at the center of most of the nuclei. And in the middle there you can see technetium in a blurred version. You can get your own copy of that over at pyramidalcube.blogspot.com, and then you can just look in great detail at the nucleus of molybdenum, magnification of 10 trillion x. Notice Dmitry Mendeleev found that his periodic table did not have a real sample, or no reports of sample, when Z equals 43. Z is the integer of the atomic number. There's 43 protons for the expected element, but it was missing. He couldn't find a sample of it himself. He couldn't find other people reporting that they found it. However, element 42 and 44 are much like, of course, 43 in atomic weight, yet they're stable. Why is this so radioactive, and why is there nothing there? And if it is radioactive, then why can't it have stable isotopes like molybdenum? Well, the answer is that element 42 and 44, molybdenum and ruthenium, came from parents like technetium, which had the cube 4 structure. So I'm going to be showing you the cube 4 structure right here. Like at the bottom center, you can see technetium has the red baryons in a cubic lattice, and then black baryons on the 6 faces of the cube. And you see iron has 3 by 3 square of red and a square for the cubic lattice. And on each of the 6 faces of iron, it has a stack of black baryons in this diagram. And it adds up to exactly 57 baryons in iron. So A equals 57, Z equals 26. Now, as far as technetium goes, you see to the left of it is molybdenum, and to the right is ruthenium with the cube 3. And so now these are clues to why eternity is based on gradual expansion forever. So in this you can see that technetium in the top right and promethium at the bottom right each has a cube 4, which is radioactive, whereas the other elements like molybdenum or zirconium have the cube 3, and that's stable. Still, even though this explains why technetium could be radioactive, it doesn't really explain why technetium couldn't have another allotrope or isotope which is stable, which is like molybdenum. So I'm going to be going over to a different picture of the cube here. Now, this is the Blender 3D software, and you can download this model yourself from the internet at Thingiverse. Now, you see there's a cube in the center here. And with Blender 3D, this can put together a technetium model using just these modules that you see here. And I'm going to show you how I can rotate all these things here. Let's see, I could select everything here in this CAD software and then rotate it around the Y-axis and rotate it around the Z-axis. And then using this kind of 3D model, you can have a hydrodynamic simulation set up later on showing the strong nuclear force. And these pieces are sufficient. I have 3 sets like this. Some have the cube 4 available, and some the cube 3. And this model actually has the cube 2 available. Move this up a bit here. Oh yeah, there's the cube 2. And I can rotate that around the x-axis here. So notice how the cube 2 is much, it has the white protons, 2 of them out of 8, and 6 of the blue neutrons there out of 8 in the cube. And this is matching chemistry, how in chemistry there's 2 electrons in the inner s orbital, matching this scheme where there are 2 protons in the inner place of the nucleus. And now I'm going to be going back to a different picture here. Now this shows the dimensions of the universe in terms of what iron does, and how there's 8 dimensions that I'm using in the expansion of the universe. And the upper level concept is that the universe has 4 dimensions, and atoms use 4 dimensions also, and they're different ones. So there's 8 altogether, as an accounting system, which I recommend. So I'm proposing this theoretical physics, and in here you can see that the green protons form 2 loops in iron. That's why it's ferromagnetic. And then the electron off on the right is this blue part over here. And there's 2 space dimensions going to the electron, and 1 time-like dimension going out of the electron back to the proton. Now this is able to create torque, unlike gravity, which is more homogeneous. It uses 3 dimensions for its force, and it's difficult for stars to exert torque on other planets or stars. But in magnets, of course, it's everyday occurrence where these 2 space dimensions are able to force a torque on electrons and protons, and conserve continuum as the magnet time goes one way and the magnet space goes the other way. EX and EY here would be, say, magnet space. And then just like in gravity, the space goes into a planet and time comes out of a planet. So the same analogy holds for this electron over here in this diagram, where the space, 2 dimensions of space are going into the electron, and 1 dimension of magnet time is going out. So this is the analogy. I would also like to go back to the PowerPoint slides here. Oh yes, and tell you what is coming up here for the expansion of the cosmology of eternity. That, say, 900 quadrillion years ago, expansion continued. All of the protons were close together, and it seemed like a neutron star composed of everything. And all the proton-electron pairs were very close together, but always moving apart in the expansion of the universe. And then, after it expanded enough, different pieces broke off. Chunks of the neutron star split apart, forming fragments, until they broke down to around cube 8, and finally the cube 4 at the center of some of the fragments. Now, these were preferentially created over the cube 3 elements. So they were remnants of the survivors of the primordial expansion, and the actual space has integer geometries in 3 dimensions. And there's a brittle kind of rule in the universe which is setting up these simple cubic structures preferentially over random nuclei. Now, molybdenum is from a cube 4 allotrope decay. In other words, what we see today in the crust of the Earth is molybdenum with the cube 3, but it came from a cube 4 in a primordial expansion. Primordial expansion. I'm just going to tell you about some of the elements which I've modeled to determine these theories with some level of certainty. Now, of course, these proposed structures have different levels of certainty. For example, zirconium, I'm 98% sure it's right. And technetium, I'm 30% sure this is right. Mercury in this picture, that's so 75% certain. Now, 100% certainty is given to the number line. So just as a mathematical axiom, 2 is more than 1, 3 is more than 2, and the number line continues with great certainty. And that's 100%. Now, iron is 99%. Now, eternity, even though we can talk about 100 quadrillion years ago, it's right now is the same. And things today are so far apart. Stars have expanded so far apart that for humans like you and me, they're just too far. People complain about how far things are apart. It's hopeless we will ever reach another galaxy in my lifetime. And on the other hand, protons do not care about expansion. They just naturally have the 8 dimensions going on of the gravity, where a proton is interacting with every other proton and neutron and electron in the universe. And also that same proton is interacting and doesn't care that it's interacting with one electron at a time for a direct force. And as an indirect force, that same proton has exclusion principles like Pauli's exclusion principle and a whole class of generalized exclusions. But really the protons don't care. They go on replenishing electrons, and life can go on forever with the replenishment of space-time in the universe. So in the 4 dimensions of space-time, there's a replenishment where time goes outwards from the planets, space drains in, but that drainage is replenished at the far fringes of the universe where fresh time, a potential fresh space is now replenishing the space that got consumed in the planets. We could make a sketch of the space-time continuum. Let's see if I have one here. Ah, yes, here it is. I show this several times, and it's just a thing which I hope I could draw on top of here for you. Now, the black part is just empty space, and the white part is time growing away from a proton at the center. The blue proton at the center is taking in 3 black space dimensions, X, Y, and Z, from the sky. And this picture only shows 1 proton with 1 electron on the left. That black circle is an electron, and into it you see the 2 red dimensions there going in, and the yellow is coming out of the electron back to the proton. So this makes a spin, and the fact that there's only 2 dimensions allows torque to be transmitted, which is different than in gravity, I was saying. As you see, 3 dimensions here. Now, the other one is the neutron is down at the bottom, and one dimension goes to the neutron. 2 dimensions go to the electron from the proton. And 1 returns from the electron to the proton. And the neutron is replenished in its lifetime with unlimited lifetime as the proton is feeding it that red line below the blue dot there of the proton. So this atom of this 1 electron and proton has the cosmology of its own. It's like its own little universe. And for example, it could be called a flatland, whereas that proton also has the complete land of gravity and inertia in the black and white. And yet it has the torque world of the electron-proton pairing in the red and yellow in this picture. And this spin can be explained in this type of arrangement. And we're trying to, scientists are often trying to minimize the number of variables. So these 8 dimensions is what I recommend. Instead of talking about electric fields and magnetic fields, we should be talking about particles. The field type of theory is really a kind of lumped functional algebra, whereas particles are eligible to be imbued with properties, chemical properties, physical properties of particles. And the 2 ways that forces can be transmitted here are between a proton and every other baryon and electron in the universe, or between that proton and 1 electron. That force between the electron and proton is a pairing, which is a deterministic pairing, and which is unlike the pairing between the proton and the sky, which is non-deterministic in 3 dimensions. Between the proton-electron there's laminated layering of determinations of which proton is paired with which electron deterministically. And there's an exclusion principle that prevents the crossing of these red lines with any other pair of a proton-electron. Now, an iron atom would have 26 little universes held together by the strong nuclear force. So what you see here is the big universe of 4 dimensions and a tiny universe of the atom with only 3 dimensions. And that 4th one goes to the neutron. Now I'm going to switch over to the camera again here and go to a different picture of some of the velocities involved. Of course, relativity is involved with velocities. And so I've come up with the velocity of the dimensions in the atom, that Ex, Ey, Ez, and Th all could have a velocity assigned as follows. As you can see in this thing, old science says that the energy of a proton is 938 million electron volts. So that's E. And in my new science, I'm claiming that the momentum of a proton due to gravity, the momentum of free space of 1 proton, is v over tau, the volume of the proton divided by 5 nanoseconds. As it says there, L equals v over tau. Now, if you take the ratio of energy to the momentum, you get a velocity. And that is the speed of light divided by 187. I'll try and move this up a little bit. Oh, there it is. The velocity equals the speed of light over 187. Now, I'm interpreting that to mean that in these pictures that I showed you before, that's the speed of these dimensions. So in other words, the red line at the top is going at the speed of light divided by 187. And the red line at the bottom is going at that speed on the average. And when they get to the electron, they're added together, and the return yellow is then the sum of the two things that go into the electron. So this accounts for how linear motors work, where there's a very linear relationship that can be used in electromagnetic actuators so that you can add together the velocities of electrons and mechanical velocities. Now, in the Cosmology of Eternity, I'm going to pause for 18 seconds here. All right, I'm back from break. Okay, we've only got a few minutes left here. I'm going to be winding up my presentation of this Cosmology of Eternity. Now, I hope I made the point there that technetium and molybdenum showed the way to this Cosmology of Eternity. In other words, the logic is as follows. A long time ago, all the matter was in a simple cubic lattice. That expanded and split off into big chunks of cubic nucleons, like neutron stars. Those expanded until finally you get down to cube 8 little nuclei. And then cube 4 and 3 as things are decaying and breaking apart. The survivors of that primordial expansion are here today in our crust. While molybdenum is here because of that, stars continually make tiny amounts of molybdenum, but that's not where the Earth has theirs from. In the final moments of the Q4s, as molybdenum was being created, there's a preferential fusion opportunity for the Q4, so that when on Earth now we try to synthetically create technetium, the Q4 is preferentially created because this is part of the primordial facts of integer geometries in nature, that the 3 dimensions are strictly enforced at the nuclear scale, and therefore preferentially Q4 will be created in your laboratories today over the cube 3 molybdenum type of isotope or allotrope for technetium, so that the survivors, these old fossils, are showing the way for explaining why that is so. Thank you very much for listening to this presentation today. My name's Alan Folsby. I'll be back on Monday, same time. See you then, or you'll see me then. Bye.